Okay. Um, in this session, I want to give you a quick overview and introduction to Eclipse, the Integrated Development Environment, IDE. Uh, the intent of this is not for you to become experts in Eclipse and its architecture and its approach. It's really to facilitate your productivity. Software tools are important. We will rely on them, and you even have an initial assignment inside of Eclipse. So this is, I guess what I'm saying is this is not the kind of thing to be on a final exam per se. Um, this is more to facilitate your understanding of the tools that we're asking you to use this particular IDE, as well as IDEs in general. So why don't we get right to it? So the objectives, familiarize yourself with Eclipse. Again, that's the IDE that we're going to use for this course. And again, hopefully give you kind of the big picture of why the IDEs and tools in general are important in software development. Um, some starting questions for you. Um, you know, so I'm sure I have developers of different capabilities. That's been the history with my students. But most students, they go through their software development curriculum, software engineering, computer science, whatnot. And they go to write code, and they'll come into my office, and they'll be in, say, even CS1, that course, and they'll bring up Windows, and they'll bring up Notepad as a code editor, and start showing me their code in that. Um, you know, think about what tools you've used so far. Perhaps you've already used an IDE. Perhaps you're using one that's not as sophisticated as what they use in industry, or perhaps you're just using a text editor with a set of command line tools. Or maybe you're already using something like Eclipse and maybe perhaps don't understand how it works. Um, the tools that you use are important from a productivity perspective, from the perspective of a consistent approach to the low level quality of your code. Next thing is one thing I'd like you to do, and I'd like you to pause this video here and go do, is go to Wikipedia and read the pages for computer aided software engineering, or what's known as case tools, and integrated development environments, or IDEs. They're not that long. I ask you to do that because case tools were kind of all the rage from late 80s to maybe late 90s for that decade. Um, and they were very costly. I'm talking about tools that were $35,000, $40,000 a seat. Some of these still exist, particularly for systems development where you're working in very custom environments. Um, Case tools largely failed as, at least for general purpose use, as being considered too big, too bulky to deal with, too costly, as you might expect at that price point. Um, IDEs are a bit lighter weight, but they still provided a number of integrated functionalities, as you'll see. So I'd like you to try and get an idea of kind of the spectrum of development tools, starting with, hey, I've got a code editor here, I've got VI, Emacs, Notepad, maybe does a JEdit, text edit, does some things for me, maybe some syntax highlighting and some indenting and things like that. Maybe I'll be able to compile code in it, to an IDE that provides some more sophisticated features and is extensible, as we will use in this class, to a full-blown case tool that pretty much is your entirement set of tools in front of you in a very integrated and custom fashion. So that's the purpose. I'd like you to take a moment and read those Wikipedia pages and just consider that question. But let's jump into Eclipse. Eclipse has been around now for a while. Project started probably more than a decade ago. Um, as a lot of IDEs are, they are today, but at the time Eclipse started, IDEs weren't largely as open and extensible as Eclipse is today, and other tools since have followed suit. Um, Eclipse wants to be resource agnostic about type, so you should install Eclipse from eclipse.org. And when you go there, you'll see there's a number of configurations of Eclipse for different languages: PHP, C++, Ruby, you name it. But its core is Java. I mean, it's written in Java, and it was originally put into the marketplace, if you will, as a Java-based IDE. In fact, you'll see a kind of a Java Everyday Edition and an Enterprise Edition of Java, as well as a Micro Edition for more embedded development kind of things. But really, its design is meant to be resource agnostic, is the point of that. And we'll see some of that when we talk about views and perspectives. We have these plugins that we will use, so it's not just to get an installation of Eclipse, it's that we'll use a range of plugins to support our topics in this course, and that's common. Normally, development organizations will rely on these quality coding tools that we'll use and even their specific configuration in order to enforce the development policies of the organization. You'll see that as this course goes on. And finally, Eclipse wanted to attract a community of developers, and they have. There's been a whole Eclipse. There's Eclipse Con, the conference that I believe is January 2016. It's been going on for years now. There's community support forums. There's a development community, a whole range of things, as well as a number of custom versions of Eclipse rebranded as commercial versions for the intent of providing that value add, and the Eclipse license allows them to do that. Okay, in terms of jumping into Eclipse, first some terminology. Three important terms. One is a workbench, the next is a workspace, the next is a plugin. And in the following slides, there'll be a number of visual relationships described between these and the concepts on the next page. Workbench is an installation of Eclipse. That's basically, you can install Eclipse more than once on your system. In fact, on my Mac, on my desk, I have 3 different versions of Eclipse, complete, distinct installations. They are configured with different plugins, including the version I use to support this class. So it's a complete, distinct installation. And Eclipse can be installed standalone. I mean, it can have its own. You can install it on a USB drive and carry it around with you, if you will. You probably won't need to mess with that. You'll have one installation of Eclipse for this class, and it should be Eclipse Mars, the latest version, and you won't have to worry about it. Now, a more interesting concept is within a workbench, you could have multiple workspaces, and workspaces are a way to partition your work. Meaning I partition my work across my research projects, consulting activities, and for my classes, including CST316. I have my own workspace specifically for CST316 in which I load all the sample code and all the labs and so forth, project code for this class, and I work in there. So I make sure I choose that workspace when I start up my workbench. And then, as I mentioned, plugins are a way for you to extend Eclipse with additional functionality. They can be provided by the community. You can write your own in order to perform custom behaviors. Some additional terms, and again, visually we'll try and make some sense of these in the subsequent slides. There are editors, views, and perspectives. So it's a development environment. You're there to write code. So there are editors to do that, to do your operations opening. This is written in a generic way, providing open, edit, save, close model for changing a resource. Think of a resource as a source code file, for example. Could be a configuration file, could be an XML file. The editor is brought up in such a way as to be custom to whatever it is that you're currently operating on. It's like double-clicking on a Word file, Word pops up. You double-click on a PowerPoint file, PowerPoint pops up. Not quite a double-click metaphor within Eclipse, but Eclipse is type aware of your resources and will bring up appropriate editors for that, as well as have appropriate behavior in it. For example, syntax highlighting based on the resource that you're editing. A view simply provides information on one or more resources, and it says there views augment editors. What that basically means is and we'll see this one in the subsequent slides. When you're developing in an IDE like in Eclipse, normally what goes on is you have a main editor pane or view that you are creating your code in, and decorated around it you'll have a set of views that give you information on things on the file system, on packages if it's Java, on an object-oriented hierarchy, on your AMP build scripts. You'll see all these things. But effectively, those things go around your main editor so that you can kind of get an idea of what's going on in context around the resource you're currently working on. That arrangement that I'm talking about, that I'm sure sounds nebulous right now, that arrangement is controlled by a perspective. All right, so when you are working in Java is a perspective. So you'll have a Java editor, you'll have a Java package navigator, a package explorer, you'll have some console for output of your Java program if you run it and compile it. You may have an object-oriented kind of class hierarchy viewer. You could have a Java doc viewer and so forth. And the perspective is what controls that layout, what you see, where it goes, and how it's related to each other. Let's take a look at some of these things. So, and again, some of the even the screen captures on here, they might look different when you bring up Eclipse based on the operating system you use, the version of the operating system, even the version of Eclipse that you use. But it's still all generally the same. Eclipse has remained pretty consistent over the decade or so that I've been using it, at least. Main thing is you see some of these things in that we've just talked about. The notion of a perspective, for example. This whole arrangement of the entire thing. Oops. Hang on. Sorry about that. The entire arrangement of these different areas over around the screen is what the perspective controls. So there's your editor that I was talking about right in the center. Here's a navigator on the file system. Here's a view that shows you what properties are associated with a resource that's currently highlighted, in this case hello world.java. Here's a task view at the bottom, things that you could bookmark, and an outline view that shows you your object-oriented view of your classes and your methods. That's just one example of what a screen might look like and how a perspective shows that. The workbench controls a single installation, like I mentioned. From a project and managing your project's perspective, the important concept is a workspace. When you bring up Eclipse and you select a workspace, it gives you a number of default properties associated with the workspace. Those are default preferences that will be mapped onto or inherited onto any projects that you work on in that workspace. Again, a workspace is analogous to a category of work that you conduct every day as a developer. So in industry, I would create a workspace for each project I would work on, a company project or product I work on, because there may be multiple development activities or projects going on within that, and I wanted to share the same set of settings, the same set of resources, and so forth. In my academic work, as I said, I create one for this class, I create one for my research projects, and so forth. So when I bring up, what will happen is when you actually start Eclipse up, you'll see that by default it wants to ask you which workspace you want to use, and you can maintain any number of them. It basically is a directory on your file system that stores all the metadata needed, including those preferences I was talking about for that particular partitioning of work that we're talking about. Workbenches in relationships to workspace. This diagram shows you two workbenches. These are two completely different installations of Eclipse. You're on Windows, that means you have two eclipse.exe somewhere. If you're on Mac, you have two eclipse.apps somewhere. Within each workbench, you can have one-to-many workspaces. As I was mentioning, you would have different workspace preferences and so forth. And then all the projects associated with that kind of work that you do. Again, CST316, I typically have a project for each one of the labs that I assign to you. I have a project for each sample code I might share with you. I have a project for each project that's assigned to the various teams in the course. So again, you have multiple ones of those. You can have different plugins installed with them, and you have different projects within each workspace. Now, even in a workspace may self-contain the resources associated with a project, as you see here on the left. What that means is, let's say you have an XML file, that's a configuration file. That can actually live physically on your hard drive under that workspace directory I was talking about. Or it could live externally and be shared with any other project across any other workspace. It could be a shared resource outside of Eclipse, not Eclipse managed at all. Eclipse does have the ability to reference resources of various kinds, meaning different files really, both inside and outside of its workspaces. Certainly when you're using something that's outside of a workspace and you're just referring to it, you want to be very careful about who else might be working with some other tool on that same resource. I already talked about this concept, so I'm not going to spend a lot of time on it. Again, this is not your work and your plugins perspective. This is showing two different installations of Eclipse, two different configurations of plugins associated with that. And again, why would you want to do that? You may want to do that because, for example, for a long time, Android development tools in the mobile platform were built on top of Eclipse. Now they're built on top of a different IDE called IntelliJ. That's what Android Studio is built on top of. But for a while, when I was first doing Android development, I had my Eclipse installation for web development, the Eclipse Enterprise IDE. I have my Eclipse for just normal desktop application development, kind of normal standard Java SE development. And then I had a version of Eclipse with the customized Android plugins, because that's what originally how Android development was done. And so those were three different workbenches. And they had different ranges of different sets of plugins and so forth, and worked on different kinds of resources and different kinds of projects. Okay, let's go back to screenshots of that. It will look more like what you're going to do. The notion of a perspective I mentioned before, and you're mostly going to work in the Java perspective, but there are additional perspectives like debugging that'll be interesting for you. And the perspective is a concept that is part of the difficulty of the learning curve of an IDE like Eclipse at first. I know when I was first learning Eclipse, when I switched perspectives and the different views on the screen kind of jumped around on me and did something else, it was a little disconcerting. I had a hard time getting used to that and understanding that. This screen shows you an example of two different perspectives. You can see the perspective name in the upper left. It says Java dash. It's editing account.java. And here's one for a database edit if you were working on a relational database, DB edit. If you look at and compare, and that's this is being highlighted for you, the menus may be different. For example, here's a connection option in the DB edit perspective. Why is that there? Well, a database you connect to, it has connection-oriented semantics. You have to create a session to talk to a database. So there is a menu option to presumably go do that inside of the DB edit. There's different things in the toolbar. Here you can see Java-based, create a new package, create a new class, whereas down here on the database side, there are different database operations here, whatever they are. And then finally, you see down here in the main aspect of the perspective, and you have this kind of tab layout, you see the different views that are in the Java perspective as configured. And again, even what goes into Java perspective can vary based on your own personal preferences. But the point is, this is indicating the Java perspective. And so I have a package explorer, a Java package explorer. I have an editor. I have my object-oriented outline of my classes, properties, and methods. And then I have my tab view at the bottom of things like problems it finds, a console for output, and so forth. Whereas over on the DB edit part, as you might expect, I have different views. Relational database, I'm talking about what different tables. So I have a couple different tables here. Now I can still have a Java file up here, by the way. Notice that this header still has the Java file up here. But that's been decided, if you will, or supported inside the DB edit perspective, as you can see here. This is what the Java perspective is, a little bit more blown up view of the Java perspective. And again, it can change a bit, but these things are fairly common to what you will see when you're working on labs in your project in this course. You should see your package explorer on the left. When you drill down into the source folder, it'll actually show you things arranged by Java packages. You normally will be editing some kind of Java source file, and that'll be here if you know, and we'll talk a little bit more about this, but things like syntax highlighting, folding, and markers are part of the properties of that editor. You may optionally decide to keep the object-oriented view, this kind of class hierarchy view, and you can double-click on any resource in here, and the code editor will jump to it, if you will. And we'll also be using Ant, and I'll be talking about that. And so you can have integrated Ant view to be able to do your builds, build scripting, and run your build scripts from within the Java perspective. With a number of I should point out too, the additional tab views down at the bottom. A lot of our plugins will make use of this bottom area because a lot of our plugins are going to be associated with helping you do defect discovery, things that could be problematic in your code. Not all of them, but several of them will, particularly when we do static analysis, PMD, find bugs, things like that. So we'll be very active and see more tabs as the semester goes on down in this bottom view. Here's a different perspective on Java, and you can see the perspective. This was the perspective we were on. This is the one that's highlighted now. This one's not used. I don't like this one as much, but there is a different Java browsing perspective. If you notice, the editor is moved, and there's more views dedicated to navigating the package, class, and method structure of the Java language. Some folks prefer navigating that way and working that way. I don't find I use it very often, but it's a different way, as well as a debug perspective. And this you might use more often in the debug. In fact, I know you use it more often because I'm going to assign it to you. But this one will tell you things like your current call stack, variables, breakpoints. It'll still have an editor in here, but that you can update with program execution. Still can have the outline view. So you get the notion. I mean, again, different perspective indicated here. You can still have the same view present in different perspectives. The perspective is controlling the arrangement of the views. It's controlling what shows up on the toolbar. It's controlling what shows up on these menus. As I said, the same views can show up in different perspectives. The most common views you see here under the Java Developer Toolkit, we'll be doing Java coding. So that's called the JDT inside of Eclipse. When you have a Java project and projects themselves are typed or have what's called a nature, then by default you'll be using the JDT and you'll be using the Java perspective within the JDT. But the common views you kind of see, again, the Package Explorer, this is a little better view. Your code's going to be organized in packages, so you'll navigate it using the Package Explorer in a package format. This kind of grid icon denotes a package to Eclipse. You can have well, let's see, the Problems tab we talked about. Problems will be something that we will work a lot in because, again, the tools will point out some inequality problems that we have with our code that both core JDT and our plugins are finding. I talked about the hierarchy navigator and the outline view already. There's also a view I didn't show you before, the JavaDoc view, so you can bring up and see JavaDocs associated. This is particularly, I mean, when you're coding, a lot of times you have to look up an API reference. Maybe it's something, a method or a class you want to use built into Java. In this case, that's what you see here, the Java lang string. Or we will be using third-party libraries, particularly in your project. As code gets larger, you're going to have external dependencies. And you can always bring up a web browser. Well, you usually can bring up a web browser and go to some kind of website to get the API documentation. But if the developers package has provided you with the Java docs, you can also bind to them inside of Eclipse and bring them up in a context-sensitive way inside this view inside of Eclipse. That's kind of nice. I mean, Java, again, is Some languages have a distinction, like C++, if you're familiar with it, will have a separate header file to define an interface. Normally, you want to know what the API is to talk to a C++ class. You're going to bring up the header file and take a look. But in Java, we don't have a separate notion of a header file, and you may not have the source. You may only have the compiled bytecode, packages .class files or as jar files, but you still need to invoke things out of that library to use its services. So you need to inspect its Java docs to learn how to invoke those things. Okay. Finally, launching Eclipse. Uh, Simple as double clicking. It'll open up anything that you have open. If you have, this is a view of a project view of different projects that are open. When you see the open folder, that means the project is open. Eclipse will open it. If you're finding that if you get a number of projects over time in this semester, you may notice toward the end of the semester that if they're all open, it may take Eclipse a while to launch. It could also cause some memory related issues with Eclipse. So if you know, hey, that's a lab I did earlier, I'm not going to be active in it, you can go ahead and close the project. This folder will show a closed icon, and you're not deleting anything. It's just that it's not active. Eclipse isn't going to load it. It's going to conserve some of its resource and load a little faster. We'll talk about creating a project, particularly when you do your lab exercise. It's like just about any other tool you work in. There's a new create a project. What is different about it is you'll be asked what type of project to create, and we'll be creating. What we'll be doing is creating Java projects. We'll also be importing projects because you can pass projects around, if you will. And later we'll even be wiring projects to our remote source code control using GitHub. I mentioned this toward the beginning, and this is a lecture is not a great way to explain these. You kind of do them. But realize in Eclipse, again, you have the notion of a workbench. That's an installation of Eclipse. It has a set of plugins that it uses. Then you have the notion of a workspace, right? That's a partitioning of your own individual work into different categories. And then you have a set of projects. Now, again, in this class, you're probably going to have one installation of Eclipse, one workbench. You're probably going to have one workspace for this class, and you're probably going to have multiple projects. You're going to have a project at least per each one of the labs that I give you, as well as for your team project that you do for the semester. Now, who knows? You may for another class, you may decide to create another workspace. Let's say. So let's say you're taking, you might be taking SER321. Using Eclipse and deciding that you want to keep that classwork separate in a different workspace. So you create two different workspaces under one workbench. The reason why this is important is at every level there are preferences defined for Eclipse as a whole and for the individual functional components of Eclipse, meaning the core features of Eclipse as well as any plugins that you've added. So for example, there's a preferences under Windows. You would go the Windows installation of Eclipse, you would go to the window menu option, and down at the bottom you would see preferences. On a Mac, you click on Eclipse itself, you'll see the preferences option, and it will bring up properties that go across the entire workbench. General properties related to fonts and so forth, Java specific properties relating to the nature of the editor, the color. You can customize just about anything, the appearance and colors of the syntax highlighting and so forth, as well as you see here DB Edit. DB Edit was one of our perspectives. It probably has a plugin associated with this, so the plugins will show up that are at the workbench level as well. But again, you can go to a workspace. Workspace will have its own preferences. That's not mentioned here, but workspaces have preferences as well. And then you go to properties on a project. So you can go into a project, and when you create that project, by default, Eclipse will use all the settings above it. meaning what Java compiler you use, what editor you use, all these kinds of things. But you'll have an option to say, I want to do something specific for this particular project. I want to use a different version of the Java compiler, let's say. And you can select that option and enable every level of customization that you need to do. We probably won't do that much customization, but some of this and some of your lab is geared around understanding where to find these things in Eclipse so you can customize. One of the one of the things I've found working with students in an IDE, well, I've kind of found two things. One is there's some students that are very good in a very specific IDE. So I get a number of students who are very good in Visual Studio. But the problem is they're completely lost on the command line. They don't understand what Visual Studio was actually doing underneath the hood to be able to create their software component, whether it's a library or an executable. Same thing, kind of thing in Eclipse or IntelliJ or in something else. The problem with that is when something goes unexpectedly inside the IDE, you have to be able to map it to what the underlying tools are actually trying to do. So let me be specific. You put a bunch of code into Eclipse, and for some reason it's not compiling. You're getting compile errors, and you can't understand why. Now, if you're on the command line, that's probably related to a class path error, which means you kind of have to understand in Eclipse this concept of a builder, so you understand how the software is built, and part of that's compiling, and you have to understand what settings actually map to that notion of a class path that you should already be familiar with. And this could be some other problem when you're learning a new IDE environment. Kind of finding those things that you know have to be there and where they are and how they're configured can be confusing, and Eclipse absolutely can be confusing in that regard. So I've constructed some lab activities to try and demonstrate that. You're going to have to look for a few things in Eclipse to get some fairly simple code to work. But in the other direction, if you don't really understand how things work on the command line, then you'll also struggle in an IDE because you need to understand how, in our case, how Java works. I mean, I will say at this point, I expect you're completely comfortable with command line tools in Java, Java-C, jar files, and that you understand the concept of a class path, because these things are still all in here in Eclipse. It's just where they are and how you troubleshoot them. And again, your lab will be something about that. So this is a little bit more about the builder. The important point for us in your lab, will emphasize this, is that you can build and run your software from within Eclipse. You can also build and run your software using an Ant, a build-in scripting tool. And then you can also take those Ant scripts and run them from within side of Eclipse, meaning you're going to not use Eclipse facilities for building and running, but instead use your external build script. But you do have the ability to run those build targets, as they're called, from within Eclipse. And again, that's something I'm going to talk about Ant as well in a subsequent video, and your first lab exercise already has an Eclipse Ant integration test built into it. All right. I'm going to skip that one. You can execute your projects from within Eclipse. In fact, this first one that you see with the main class, that's going to be one you do in the first lab, the Hello World type project. It will show you the console, the output that you would normally see at the command line in your DOS window or in your bash shell, in the console tab at the bottom view of your Eclipse pane. It's fairly straightforward. You can right click on any Java class that has the public static void main in it, and select run as Java application, and it should run. Now it gets a little bit more interesting when you have command line arguments of different kinds that need to be passed for, and that's what you see down here at the bottom. You have command line arguments, some the name of a file, a value passed in at the command line. That equates to Java space first dot project dot main class space 25, let's say, or 10, I guess the console output shows. Another thing is you may want to select a different JRE. You may have more than one version of Java. You may have a version of software. I mean, the latest version is 1.8. It's what I assume in this class. However, you may find that uh, somebody has a legacy version and you need to run 1.6 or 1.4. And you may have that installed in your system and you have to select a different JRE than the default. Same thing with the class path. You may need to set a custom class path for running the program to make sure that all the external resources needed by your program are present. In terms of code editing, and I, there's a lot to the code editing part. I mentioned syntax highlighting, all right, already, but you know, if you're using a plain editor and you're not used to a more sophisticated editor like is built into Eclipse, some things can be a little disconcerting at first because it seems kind of noisy. So looking specifically at this bottom view down here at the main.java, what you see are things, adornments and highlighting in the main body, in the tab, in the left margin, in the right margin, what is going on. Most modern editors nowadays will tell you when it thinks there is an error going on. It has a built-in incremental compiler. So for example here, X is not declared to be an int anywhere within scope. So it's underlined there that that's a problem. The line is highlighted on the right. It's also highlighted on the left. In fact, if you hover over that marker, as it's called, it will tell you what the error is and give you an option to fix it, to do what's called a quick fix on it. It'll also do warnings. If there's something about, I'm not sure what this warning is, but there's something that Eclipse is worried that might be incorrect in your code, it will give you the warning symbol on, again, both the left and the right and in the code editor if need be. Finally, you'll notice if there's a problem in your file that keeps it from compiling, the tab adornment is highlighted. The problem is noted in the package explorer within the specific method that's a problem. Notice we have an error and a warning here. And notice how that problem is also percolated all the way back up the tree. So that if someone's not looking in the expanded view like this, they're looking in the compressed view, they would still know there was a problem in main.java or in the default package or somewhere in their source tree. Likewise, over in the outline view, same thing. It'll adorn it wherever it thinks there's a specific problem. As soon as you fix this, if we type int x there and resolve this error, all these red markers are going to go away in all of these views pretty much instantaneously. So it gives you a nice idea of where problems are in the code no matter which view you're looking at. I should want to say markers are also going to be important because again, just like I mentioned the problems view tab before in the bottom view, a lot of our plugins are going to give us visual alerts through these marker concepts, almost to the point that they're too noisy. But again, that's going to be one of their configurations. So it's not just compile errors. A plugin might actually also indicate an error according to whatever policy you set for the plugin by using these same kinds of markers, and that's why I wanted to talk about them. I've talked about a number of this stuff already. I'm not going to belabor the point. You can read it, but again, modern source code editors normally try and do everything they can to help you discover a defect as soon as you inject it. Instead of, again, in the old days, I would be coding C in Emacs. Emacs might have a nice editor mode for me, but I was on a black and white screen. I wouldn't get syntax highlighting. I might get some auto indent. I'd go, I'd shell out, I'd compile my code, I get a bunch of cryptic compiler warnings, and then I'd have to go find out where the real problem is. These editors nowadays, far more powerful, try and use syntax highlighting, as well as give you a lot of productivity benefits, code completion, looking up the Java docs, all these kinds of things, automatic refactorings, generating stub code, to really make you both more productive and reduce your kind of silly errors that you make that can be quite time consuming. That's it on specifics of Eclipse. And again, It's IDEs are kind of this religious war thing. Everybody's got their favorite. There's different camps. I've used NetBeans, IntelliJ for a long time. The big three were Eclipse, NetBeans, and IntelliJ. Um, and they're all still out there. There's some newer editors that are coming around with new forms of development. So I teach in the web and mobile area, as I mentioned before. New JavaScript, HTML5. I was trying to do JavaScript editing in Eclipse. It's actually kind of painful. Um, I have more luck with things like Sublime, Atom, and brackets. So they can be very language specific. They can also be operating system specific. So, right, you can go into Visual Studio on Windows and just about any of the Visual Studio languages popular on the Microsoft platform are supported within it in different modalities. Likewise on Xcode, you're doing Swift, you're doing iPhone development, you're doing Objective-C. You'll have a lot of facilities built in to Xcode to support those kinds of languages specific to that operating system. Again, in summary, what are some of the benefits of IDEs? Productivity, you're saving keystrokes, you're providing some basic automation of very low level tasks. It's extensible, this notion of, again, these plugins that you can add to Eclipse, common in other IDEs, these integrations provide directed functionality appropriate for what you have to do every day as a developer. And again, IDEs can enhance quality. It finds a lot of problems that in the old days would require this little round trip between compile, go back into the editor. Now the IDE is going to find it pretty much as soon as you type it. I'll even say that Eclipse can be a little bit annoying. It'll start telling me I have an error before I've even finished typing the line of code, or it'll start popping up a code completion dialog, and I'll fat finger something, and next thing you know, some method I didn't intend appears, and I have to undo it and redo things and so forth. So it's very aggressive and very fast with these kinds of things. Some of the drawbacks. Um, uh, the first one, builds may not resemble downstream builds. What do I mean by that? I know we haven't talked about build management yet. What I mean by that is, and I find this a lot with students as well. They'll come into my office on office hours and show me a program that's working that they run directly out of Eclipse using the run as functionality. But then we'll go out to the DOS prompt and try and run it at the command line, and it doesn't work. And I don't understand why it doesn't work because again, Eclipse has set up a builder that helps them construct the executable software product, and it also has its own places where it configures the runtime that's actually executing your program in. And a lot of times the defaults work, and they don't understand what's going on. And then they go out to the command line. They don't know how to set the class path. They don't know why the directory structure is wrong. Um, or maybe they got it working in Eclipse, but the ant script doesn't work, and they don't understand why. So sometimes the builds are a little bit behind the scenes, and the build process can be different in terms of what's built into the ID versus what you're actually going to do when you hand it off to somebody else. And what I mean by that, as a developer, you may hand it off to QA, to a tester, and ask them to run it. Well, they're not going to run it out of Eclipse. They're going to run it from your ant script, or they're going to run it from a shell script, or through a test script that tells them a sequence of commands specifically to type. And anytime what you're doing as a developer is different than what the folks downstream, meaning after you do, there's a possibility of some frustration coming in there and some time spent trying to figure out why these things are different. Learning curve, migrating with revisions. Again, I wanted to get you started with Eclipse right away because if you haven't used it and you haven't used something like it, it can be counterintuitive. So I want to make sure you are aware and get up to speed as soon as possible. And then the other thing is things. There's revisions even with the labs that you do and the plugins I use. Every year, every 6 months, I have to go out and revisit, make sure a plugin's supported, make sure it works with the latest version of Eclipse, and they don't always do, and sometimes they can be quite frustrating. Although that's probably the same with any tool you're going to use nowadays. And then finally, could add CRUD to your source code control repository if you're not careful. So, for example, I'll give you a specific example that may not make sense today, but should in a week or so. Um, and Eclipse keeps track of project-specific information by putting two hidden files in your project directory. It'll put a .class path and a .project file. So if you view hidden files in Windows Explorer, or if you go to a shell and look at, do an ls-la or something, you'll see these files. And the issue that happens is, those files will have information specific to your environment, things like directory paths, and things like maybe you configured where your Java is, or how much memory you want to allocate to Java when it starts up. Those things are specific to you. That's not stuff you need to share with your team. But if you don't configure Git appropriately, Git will push those files up to your source code control repository, and it gets kind of ugly when somebody else gets your metadata and it overwrites their project, and they've lost their configuration and things like that. So we'll talk about some of that when we do with Git. There'll be a way in Git that we use something called a git ignore file to try and prevent those kinds of things from happening, so you don't accidentally blow away each other's configuration of your Eclipse environment. Okay, that's it for IDEs and Eclipse. That one on quite a bit, I know. And really, I think you're going to learn more about Eclipse by doing the lab exercise where you have to go in and get your hands dirty with it. Prepare as always with a new tool. There will be some frustration. There'll be some, where the heck is this thing? Please use the discussion forums. But I think in a short time you can become quite proficient with it, and you'll be prepared for the rest of the labs and the project and the course.